Welcome to Mesh Learning's GCSE Chemistry, adapted from Talio, and we're going to be talking about the ever-changing Earth, focusing on continental drift, and then the next lesson we'll be focusing on the atmosphere. So we've got three objectives, and we're actually going to tackle them A, C, B, but these are from the specification. Useful to know what you're supposed to be learning. It's the large-scale structure of the Earth in terms of solid iron core, molten iron, outer core, mantle, and crust. You need to be able to label this up. So we start off with the crust, which is the thinnest layer of the Earth structure, between 5 kilometers to 70 kilometers below the continents. Interestingly, there are some massive lakes underneath the and oceans that are underneath the crust. So where the cracks are formed and the water has gone in underneath, there's actually quite a lot of water trapped in layers underneath and forming massive seas. But if we shrunk this down to the size of a golf ball, it would be smoother than a snooker ball. Right, so all those divots, if you ever climbed up a mountain, well, the size of the Earth just means that it's if you could shrink it down to that size, it would be absolutely beautifully smooth. The next layer is the mantle, core meaning is the thickest layer of the Earth and contains semi-molten rock. So technically that's called a plastic. So plastic means flexible or fluid, so metals can be plastic as well. So in this case, the rock is actually plastic. It can flow. That's what it means to be. So if you heat a metal up enough, it becomes plastic and is able to flow. So it's more like a liquid, but it isn't a liquid. It's a plastic, solid, semi-molten rock near the core, and this obviously comes out during volcanic activity. Then we have our inner core, the hottest part of the Earth. The temperature can get as high as 6,000 degrees C, and it's mainly made of iron with some nickel. Whereas the central core, the inner core, is the hottest part and can get as high as 6,000 degrees, which in certain parts is hotter than the surface of the sun. Now, the inner parts of the sun are millions of degrees, but the outer crust of the sun, in the sunspots, where they're cooler parts, are cooler than the hottest part of our planet. And it's mainly made of iron with some nickel too. So crust, mantle, inner core, outer core. Crust, mantle, outer core, inner core. Crust, mantle, outer core, inner core. Now, you don't need to know how we know these things, given we've never drilled through the crust, but we have used earthquake data, we've used explosives and very, very sensitive seismometers across the world to be able to map what the different structures are like, because waves follow basic physics principles and they follow laws of physics. So when they travel a particular way, they give us this map of what's happening inside the planet's surface. And this can only be a solid core given the way that this works. And we know this is molten because sometimes it creeps through the crust.